Hi friends, we are in Algebra 1 looking at section 1-1, variables and expressions. The first thing we need to talk about with every chapter is any new vocabulary, and so even though some of this information might not be so new to you, I'm going to make sure that you're at least somewhat comfortable or familiar with these terms as we move through this chapter and specifically this section. So the first word we have is variables. Variables are letters that are used to represent numbers. So I might say something like, I'm hopefully going to get paid this week. And when I get paid this week, P amount of dollars, I already have $50. So the amount of money I'd have altogether would be P plus $50, where P is the letter that's being used to represent the amount that I would get paid. And so what I've created here, indeed using this variable, is an algebraic expression. It's an expression that includes variables, sometimes doesn't include variables, that shows relationship or represents a situation, and that's what I just did. Factors are numbers that divide evenly into another number. Factors are numbers that divide evenly into another number. So for instance, the number 24 has several factors. So the factors of 24 would be the following: 1, which is a factor of everything; 2, 3, 4, 6, because all of these numbers divide evenly into 24. Let's think, what other factors do we have? So we also have 8, we've got 12, we have 24 itself. Am I missing one? Can you think of one that I'm missing? One cool way to figure out if you have all the factors is to make sure you see what numbers multiply together. So 24 times 1 is 24, 12 times 2 is 24, 8 times 3 is 24, and 6 times 4 is 24. I think I got them all. So here are the factors of 24. Factors are numbers that divide evenly into another number. Product is the answer you get when you multiply two numbers. So let's say we were talking about the product of 6 and 7. The product of 6 and 7 would be the answer I get when I multiply those two numbers, which is 42. The next thing we're going to talk about, or the next term we should be aware of, is the word power. Power is especially important when we're talking about, well, honestly, it really relates very much to this word here, exponent. An exponent is the little number that we have in a situation like this, 3 to the second power. So power refers to the number up here that we are raising 3 to, and exponent is also the actual name of the number. So how do I deal with this, or how do I evaluate it? How do I represent this as a single number? Well, we all know that this little 2 tells me how many times I'm multiplying 3 by itself. So this tells me 3 times 3, and so we know 3 to the second power is 9. The next term that we should talk about is base. And the word base, let me get a highlighter here. The word base refers to the number 3 in this expression. So this expression, 3 to the second power, is 3 times 3, and the base of it is 3, and the power, or the exponent, refers to the number 2. Let me use my highlighter to show that a little bit better. The final term that we're going to talk about today for our vocabulary is to evaluate. To evaluate means to get an answer, get a numerical answer for something. So if I say evaluate the following expression, if A equals 3 and B equals 2, I'm now defining these variables, by the way, and I say evaluate A squared plus B minus 1, what this tells me to do is evaluate means to get a numerical answer. So at this point, I would put 3 to the second power here, add 2, subtract 1, and figure out what this is. 3 squared is 9, plus 2 minus 1 is going to give us 10, because we're going to go from left to right. 9 plus 2 is 11, minus 1 is 10. All right? So that's it for vocabulary. Let's get on to some example problems. One of the most important things to be able to do when we are dealing with algebra is to take verbal expressions and turn them into algebraic expressions, okay? So we are given in this particular one, h more than a number n. We're given the variable Sometimes we're going to actually have to make up a variable on our own or define a variable for a given situation. But here, if we're talking about more than, I hope that you know that we are adding something. So 8 more than a number could be written as 8 plus n, or you could also write it as n plus 8. Let's take a look at this next example. The difference of 7 and 4 times a number x. So hopefully you recognize the word difference is referring to subtraction. So right here, we know that we're dealing with a subtraction problem. We're talking about the subtraction between two things. What are the two things? 7 and this thing, 4 times a number x. Well, in algebra, we don't need to write 4 times the number x. We're just going to write 4x. The multiplication here is implied. So what I'd write here is 7, the difference of 7 and, so difference of 7 and some other number, 4 times the number x, and I'd write it just like that. This final example, or this final part of example 1, is 1/3 of the size of the original area A. So we're talking about an area A, and we're dealing with 1/3 the size of that thing, of A. When we talk about 1/3, it would be 1/3 of something. Somebody probably told you that 1/3 of a value, of means multiply. Of doesn't mean multiply, but oftentimes in mathematics, that's exactly what you're supposed to do. 1/3 of A would simply be 1/3 A. Let's take a look at example 2. When we discussed our definitions earlier, we saw this word product, so I just want to highlight it really quick as we talk about this particular example. In this example, we're going to write algebraic expressions with powers. Write each expression algebraically, so we know what that means. We know we're going to write it using variables, right? So the product of 7 and something else, m to the 5th power. Product, we remember, refers to multiplication, so we're multiplying 7 and something else, m to the 5th power. I told you before that when we are dealing with multiplication, oftentimes we don't actually write a symbol down in between it, particularly when it's multiplication between a number and a letter. So in this case, we write 7m to the 5th power. Let's take a look at part B. The difference of 4 and x squared. Difference of two things. We've got the two things 4 and x squared. Difference we know to be subtraction, so we're talking about 4 minus x to the 2nd power. Let's check out example 3. Here in example 3, we are being asked to evaluate each expression. Remember earlier we said evaluate means to give the numerical answer of something, so that's what we need to do. We know that this power, this value, this exponent 6, means to multiply 2 6 times. Well, I should say multiply 2 by itself 6 times. So I'm multiplying 2 times 2 times 2 times 2 times 2 times 2. And what I'm going to do is get the answer. And when I multiply 2 times 2, I get 4. Times another 2 is 8. 8 times another 2 is 16. 16 times another 2 is 32. 32 times another 2 is 64. So my answer is 64. Let's take a look at this next example. So we're going to take 4 and raise it to the 3rd power, which we know means 4 times 4 times 4. 4 times 4 is 16, times another 4 is 64. We have evaluated both of these expressions. Here we are with example 4. We're going to write a verbal expression. So we're going to start off with an algebraic expression, and we're going to write a verbal expression for it. So when I look at this guy, I'm like, okay, 4 is being multiplied by m to the 3rd power. A word that we use sometimes for multiplication would be product. So I can refer to this as the product of 4 and m to the 3rd power, or sometimes we call things to the 3rd power cubed. So the product of 4 and m cubed. So I want you to also realize that it would not have been a mistake for me to go 4 times m times m times m, or to say that, to write that down as the verbal expression, or I could have said 4 times m to the 3rd power. There's a number of ways to do it. This is just one, so your answers to some of these questions might vary, but as long as they represent the same thing, we're good to go. In this problem, I noticed that we're adding, so the word sum could be used. I might say the sum of c squared and 21 times d. If I wanted to get sassy, I guess I could have talked about the sum of c squared and the product, the sum of c squared and the product of 21d. Sometimes or 21 and d, sometimes it gets a little bit convoluted when we use too many vocabulary words all together trying to get an expression out there. So I want you to just take your time, do your best with the examples and the problems that look like these. Here we've got 5 to the third power. Remember last time what we said? We said that 5 to anything to raise to the third power with an exponent of 3 is referred to as cubed. And that's why this shape is being represented here. So basically you've got two possible choices. You could either write 5 to the third power or 5 cubed. You're not required to do this section, but I sometimes like to add a little bit of opportunity for students to do practice problems right here with me, quote unquote. So I'm going to ask you if you feel like doing a couple practice problems. I'm going to read the question, then I'm going to put the answer right after it. So you should pause me if you're going to do them either either in your mind or you're going to do them on paper. So let's look at this first one in the guided practice. The sum, write an algebraic expression for each verbal expression. So the sum of j and 13, the answer to that would be j plus 13. 24 less than 3 times a number. This is a little tricky, so I want you to think about it before you do it. Their answer here would be 3n minus 24. If you have 24 less of something, that means you got to take 24 away from the thing. And I'm using n as the number in this case. Evaluate each expression. Go ahead and give number 6 a try. I hope you got 81 as an answer. How about number 7, 4 to the 4th power? I hope you got 256. Number 8 and number 9, we're going to write a verbal expression for each algebraic expression. I'm going to hold off on the answer for this one. Please ask me, send me a text or something if you need the answer desperately, but I think you guys know how to do that. Let's look at this one, application number 10. Money. Lorenzo bought several pounds of chocolate-covered peanuts and gave the cashier a $20 bill. Write an expression for the amount of change he will receive if P represents the cost of peanuts. Write your answer down or think of your answer and check it out. He should get 20 minus P as change. All right, you are now totally ready to do the assignment. Go ahead and make your best effort, and I look forward to hearing from you and talking to you soon. Take care.